before we get into the presentation, I wanted to introduce First Line Technology for those who may not be familiar with what it is that we do. For most, we are the Decon company, and while that's true, it isn't all that we do. First Line is focused on helping our military, first responders, and healthcare first receivers work smarter and safer during real-world emergencies. The company takes proven science from the lab, whether it's in chemistry, materials, or logistics, and turns it into practical life-saving tools that can be deployed in the field. Our systems are designed around one idea, and that's making response simple, faster, and more effective when every second counts. So we've taken the company and we've transitioned it into these four product verticals where we look at ambibus doing mass casualty, transportation in the event that there's a mass casualty incident. Instead of having one dedicated ambulance for one person or maybe two people, we have the ability to move multiple patients at a time. And this is from a nursing home to a hospital, hospital to hospital, from a standalone position for we'll say like a mud runner or a Spartan race or any kind of large events, but we had that ability to move multiple patients at a time. And then phase core is our heat stress prevention technology where we can help regulate body core temperatures and things like that to help essentially stay in the suck a little bit longer. That's kind of the way I like to put it. For folks that are wearing suits, we have the ability to provide capabilities to, again, regulate that body core temperature and prevent a lot of the issues with heat stress. And then the big focus today is the Decon Tech program along with FLUA, kind of what we're doing here, the online and in-person training that we offer on all of our products, but more specifically for our Decon stuff. So Dahlgren Decon, FiberTech, and the kits that those kind of fulfill. So knowing where Decon started really helps us understand why we do things the way that we do today. Every major event that's involved contamination, from war zones to industrial accidents, have forced people to find better ways to protect others and clean up dangerous materials. The tools and methods have changed over the last century, but the goal was never wavered. Keeping people safe and getting operations back on track as quickly as possible. When we look back at the past, we see how trial, error, and necessity built the systems that we rely on now. The lessons that we use today were paid for through real-world experience. In World War I, the first major chemical attacks showed why why speed mattered most. Troops had almost no time to react before gas injuries became fatal. Decades later, the Cold War brought a different lesson: the importance of safety. Decon agents like DS2 could neutralize nerve agents, but were strong enough to burn through paint, equipment, and sometimes even our protective gear. Now, in more recent times, the anthrax attacks reminded us that simplicity is just as important. A process that's too complicated can fall apart when people are under pressure. Each of these moments in the early days taught us something new about balancing chemistry, logistics, and human performance. Decon was purely a military effort early on. Specialized teams operated under these strict conditions using heavy equipment, harsh chemicals, and over time, those same principles were adapted by firefighters, paramedics, hospital staff who now face hazardous situations in cities and neighborhoods instead of on the battlefield. The science came from military research in most cases, but the practical application was refined by civilian responders who had to make these methods work in real world settings. And that partnership between the military precision and the civilian adaptability is what makes modern decon so much more effective. Another reason why history matters is that progress usually follows failure. When equipment breaks down or a response doesn't go as planned, it drives improvement. Every major setback in decontamination, specifically, whether it was a battlefield mistake or a breakdown in communication during an incident, pushed people to rethink how to do it better. Out of those lessons, we developed stronger procedures, safer materials, became better at coordination among our agencies. But ignoring those facts, those lessons, means we risk repeating the same mistakes that the others have already learned from. So as we move forward through the presentation, keep three simple ideas in mind for me. Each new challenge has forced innovation. Every advancement in tools and chemistry has aimed to protect responders and victims and casualties alike. Every refinement over time has made the process faster, safer, and easier to carry out. Those ideas, the speed, safety, and simplicity, have now guided decontamination for over 100 years, and they're going to continue to guide us as new threats and technologies emerge. So real quick, kind of looking at the very early components of decon, right? Where before decontamination became this structured process, it started as pure improvisation. When chemical warfare first appeared in World War I, there was no established doctrine, no specialized gear, no real understanding of what worked. Soldiers were forced to rely on the most basic types of materials: water, dirt, rags, and to try and remove or neutralize contaminants. The first attempts at decon were simple mechanical actions: wiping, scraping, or washing contaminated clothing and weapons. Using lime, sand, sodium hypochlorite, or bleach were some of the few chemicals that were available for neutralization, but they often did as much harm as good, corroding metal, damaging fabrics, and burning skin. These crude methods were reflected a time when decon wasn't yet a science. It was a desperate act of damage control, essentially. Technology was minimal. Water pumps and brushes and field basins were the main tools where we really just focused on applying as much water and soap to the problem as we could to try and do the adage of the solution to pollution is dilution. Most decon stations were little more than wooden platforms or trenches filled with water. Soldiers had to clean gear by hand, often without the appropriate levels of PPE, so no gloves or masks. There was no containment, no monitoring, and no recovery phase, just a hope that washing in time would reduce the hazard enough to keep moving. So darn it, even though these efforts were relatively undefined, they introduced two ideas that would shape how decon was conducted forever: the importance of removing contamination quickly and the need for chemical neutralization rather than just dilution. These earlier lessons kind of paved the way for that formalized decon procedure that was developed later in the war, where research, organization, and chemistry finally began to catch up with the threats. So then we get into the birth of decon. So World War One was where the idea of decontamination truly began. It was the first conflict to see large-scale chemical warfare, and it caught nearly everybody unprepared. Troops on both sides faced chlorine, phosgene, and mustard gas, agents that lingered in the air, soaked into the soil, and clung to clothing and equipment. There was no protective gear outside of these, the very rough on the right side picture there, the over boots and rain slickers. And there was no formal decon process, of very little understanding of how these chemicals actually worked. Soldiers relied on desperation and improvisation more than science. Some tried washing with water, others used bleach or sand, and many resorted to burying contaminated gear just to avoid the further exposure. It was chaotic, but it was also the start of learning what actually worked and then also what didn't. So one of the most important lessons from that era was that speed saves lives. Soldiers learned that the sooner they could rinse off or move out of a contaminated area, I don't know why it keeps doing that. I apologize. But moving out of that contaminated area, the better their chances were of survival. Mustard gas, in particular, had delayed effects. By the time the symptoms appeared, it was often too late. The realization gave birth to the first structured attempts at chemical defense. The British, the French, and later the American forces began to organize smaller units specifically tasked with understanding and responding to chemical threats. These early efforts kind of laid the groundwork for what would later become formal chemical corps and decon teams. Protective gear also at the time was primitive, as I had mentioned, but it represented a leap forward from nothing at all. The early gas masks were made from cotton pads soaked in chemicals like sodium thiosulfate, which was intended to neutralize some of the gas before it reached the lungs. They were uncomfortable, often ineffective, and offered very little protection against some of these stronger agents. But they showed that prevention and decon could work together as part of the same problem-solving approach. So by the end of the war, more sophisticated mask designs and crude decon solutions were beginning to be distributed as a standard issue. Another major development from the period was the recognition that chemical contamination wasn't just a battlefield hazard. It could spread quickly and affect entire areas, making cleanup just as important as the immediate threat. So military leaders started to think beyond survival and began to consider recovery, how to return contaminated ground and land and equipment back to usable conditions. Though these techniques were very basic, the mindset marked the beginning of operational decon as a military capability. So World War I forced the world to confront the reality that chemicals could be just as destructive as bullets. It created the need for research, procedure, and most importantly, structure. These lessons carried forward into every conflict in the future in civilian emergency response system. The concept of decon was no longer a reaction born of essentially panic. It became a discipline guided by the chemistry, the timing, and honestly, more importantly, the logistical coordination. So World War One really didn't just start the story of chemical warfare. It started the story of how, we learned to fight back against it through decontamination. So when we get to World War II, military planners knew that chemical weapons were a real possibility, and this time they came much more prepared. The lessons from World War One had made it very clear that chemical defense and decontamination needed structure, training, and science, not just improvisation. So as a result, specialized chemical warfare service units were formed, dedicated entirely to managing detection, protection, and decontamination on a large scale. Decon had officially become a coordinated operation instead of a last-minute reaction. The war brought many new threats, including lewisite, different versions of phosgene, and tabin, one of the world's first nerve agents. These agents were far more toxic and persistent than those used during World War One, which meant older methods like the sand and water and the basic bleach solutions were no longer effective. To meet that challenge, chemists and engineers began to develop stronger, more targeted solutions. Early versions of those compounds would eventually inspire DS2, which I'll talk about here in the next few slides. One of the most widely used decon agents of the next few decades, which this again appeared during this time. These were still harsh chemicals, but they marked the first real step towards standardization in decon chemistry. World War II also saw the first truly organized decon operations. The U.S. and British militaries built decontamination stations for troops, equipment, and vehicles. These stations often included sprayers and wash racks and chemical application systems that could handle the large-scale contamination events. Entire battalions were trained in decon operations, with each being responsible for managing their own protective equipment, handling the contaminated gear, and then restoring vehicles for continued use. And this was a massive leap from the scattered, improvised, reactive efforts of World War One. Another major milestone during this period was the introduction of civil defense programs at home. Allied nations, recognizing the possibility of chemical attacks on civilians, began training ordinary citizens in emergency protection and decontamination procedures. Posters, handbooks, and community drills were used to teach families how to recognize the chemical exposure, wash contaminated skin, and then safely dispose of clothing if necessary. So while the attacks never came to the Western cities, these preparations represented the first time that decontamination had truly crossed from the battlefield and into that civilian population. The World War II era also really drove this connection between decon and logistics. A contaminated tank or airfield wasn't just a safety issue, it was also a strategic one. The faster a unit could clean equipment and return it to service, the faster the mission could continue. This thinking, that decon could preserve operational readiness became one of the central principles of modern CBRN response. It shifted that mindset from cleaning up after the attack to maintaining the ability to fight through one. So while the world ultimately avoided widespread chemical warfare in World War II, the preparation for it shaped decades of doctrine that followed, some that we're still following today. The systems, the solutions, and specialized units developed during that time provided the backbone for Cold War era decon programs. It was also the moment when decon became a true profession, one that combined the chemistry, the engineering, and logistical efforts to protect people and maintain capability. The war might have ended without large-scale chemical attacks, but the groundwork it laid ensured that militaries and then later civilians would never be caught unprepared again. So, the end of World War II brought the beginning of that nuclear age, getting into the 1950s, 1960s. And with it came an entirely new kind of contamination threat. For the first time, the concern wasn't limited to chemical agents or toxins, it was radiation. To me, that's much more scary. The things that you can't see in most cases is what causes me the most concern. But the fallout from nuclear testing and the atomic bombings of Japan made the world realize that contamination could spread invisibly, like I'd mentioned, over entire regions and remain hazardous for years. This really set the major shift in decontamination. We'll call it the rise of radiological decon.
Oh,
Yeah. If you can mute your mic, I would appreciate that. Sorry about that. But yeah, this was kind of the rise of the radiological decon and the birth of these civil defenses as a public responsibility. So during the
Okay.
1950s and 60s,
All
these
right.
nations around the world, and
Okay.
I apologize real quick, everybody.
It's
If you could just
11.
mute your mic for me, that would
Mid
be
21.
fantastic.
Well, I called him last night and he said somebody didn't show up and they didn't get to it. And so I said, well, then put it inside and,
Hey, Elizabeth
work on
or
it
Danielle,
again
anything we can
today.
figure out who this is real quick? Sorry, everybody. Just want to make sure that we're all on the same page here.
Yeah, Frank, he's muted. You're all good.
All right. Thank you very much. All right. Hopping back into it. All right. So during the 1950s and 60s, these nations around the world began developing programs to protect their citizens from potential nuclear attacks. So in the United States, the Federal Civil Defense Administration led massive public education campaigns. Families were encouraged to build fallout shelters, store food, water, and learn basic decon procedures in case radioactive dust settled on them or around the property. This was the era of the famous duck and cover drills that were in schools and community pamphlets that taught citizens how to wash radioactive particles from skin and clothing. So it might seem simple by today's standards, but it represented the first large-scale effort to teach decontamination to the general public. So in military circles, radiological decon introduced new technical challenges. Unlike chemical agents that often could be neutralized, radioactive contamination required physical removal, the brushing and washing and scraping of particles from surfaces and clothing and equipment. This this shift forced militaries and scientists to develop new materials and techniques. With this came high pressure washing systems and specialized cleaning agents and radiation detection instrumentation. It required a better understanding of dose management, especially since responders could be exposed while attempting to clean those affected areas. The principles of time, distance, and shielding also became central to both military and civilian radiological response. So the Cold War intensified those efforts. With the threat of nuclear conflict looming, preparedness became a national priority. Civil defense organizations ran large-scale drills simulating atomic strikes, and this was complete with mock fallout zones and public decon stations. The communities practiced washing contaminated individuals, monitoring exposure levels, and disposing of radioactive waste. Now, although these events were more about readiness than actual necessity, they had this really long-lasting impact. They normalized the idea that decontamination was not only possible but essential, for recovery after a disaster. So this era, really expanded the psychological aspect of decontamination, the fear of radiation, where something is unseen or poorly understood by the public, created widespread anxiety and distress. The civil defense training aimed to replace fear with procedure, the practice by muscle memory. By teaching structured steps for washing, isolating, and monitoring, the government's hope was to give people a sense of control in a situation that otherwise felt uncontrollable. So that approach to public reassurance through process is still visible in today's emergency communication strategies with the PA systems that we have and all the alert systems and cell phones and all the capabilities that we have through technology. But the nuclear age didn't just add a new type of contamination. It fundamentally broadened the purpose of decon. It was no longer limited to soldiers and first responders, as it became a part of civic duty, something that every household was expected to know at least a little bit about. So the combination of science training and public awareness during this period built the foundation for modern radiological and all hazards preparedness programs. In many ways, it was the first time that decon had stopped being seen as a specialized skill and started being recognized as a shared responsibility, something that combined the national readiness, community awareness, and then the personal actions. All right, so as the Cold War stretched into the 1960s and beyond, the idea of decontamination became more technical and disciplined. Nuclear, biological, and chemical warfare were now grouped together under a single doctrine, NBC defense. This was where this was the first time that decontamination was seen as part of a complete protective system rather than a single task. The mindset was still clear, though. It wasn't enough to survive an attack. Forces had to be able to keep operating afterward. And that shift gave birth to more standardized tools, chemicals, and procedures that were designed for quick use under those stressful conditions. One of the biggest developments of this era was the creation of Decontamination Solution 2, or simply known as DS2. It became one of the most recognized decon solutions of its time. DS2 was extremely powerful. It could neutralize nerve agents, blister agents, and a range of other chemicals. And it worked well, but it came with many serious drawbacks. It was extremely toxic, very corrosive. It could damage most surfaces that it touched. And this is everything from vehicle paint to human skin. But despite those issues, it became the gold standard for decades because it was versatile, available, and most importantly, I guess, easy to use in the field. Crews knew that if they needed something that worked fast, DS2 was the go-to option. The military also developed new tools and things to apply DS2 efficiently. Systems like the M11 and M13, which are pictured here, the portable decon sprayers. These allowed soldiers to carry out these quick targeted cleanings on vehicles and weapons and other protective gear. These kits were much more compact, they were pressurized and simple enough to be used under those combat chaotic conditions. They represented an important move towards mobility. So now decon could happen at the edge of the battlefield instead of well far behind it. The idea of immediate operational and thorough decon, the three levels of response, depending on the situation, became standard practice during this time. So some other things that were great, though, was the protective gear also improved significantly during the NBC era. The introduction of MOP, or mission-oriented protective posture levels, allowed troops to adjust their protection based on the level of the threat. This was a standardized system that meant every service member, regardless of branch, understood what to wear, when to wear it, and how long they could safely operate in those contaminated environments. The combination of better suits and respirators and now standardized decon procedures made it possible for units to continue working in conditions that would have been completely impossible a generation earlier. So training during these era became much more realistic and physically demanding. Soldiers practiced decon drills using full gear, real sprayers, and mock agents, all under timed conditions. They were taught to think of decon not as just a cleanup, but as part of mission continuation. The priority was to get troops and equipment back into the fight as fast as possible. This was a practical and repeatable style of training that essentially became the foundation for modern CBRN instruction, which is used by militaries around the world. Now, at the same time, scientists and engineers were also researching safer and less corrosive alternatives to DS2. Environmental concerns were growing, but the dangers of handling such a harsh solution were very well known. These early studies would later lead to the development of milder and more quote unquote environmentally friendly decon solutions. But during the height of the Cold War, performance came first. The goal was simple: to neutralize the agent, save the operator, and restore the mission. So by the end of the 1980s, decon had become faster, much more consistent, and way more integrated into every branch of the service. NBC Defense had moved from a specialized skill to a core capability. So while the Cold War never turned into a global conflict or chemical conflict that many feared, the training and technology developed during that time prepared both military and civilian responders for the challenges that came next. The DS2 era might have been pretty rough on equipment, but it cemented this idea that decontamination was as essential to readiness as the weapons or the logistics. All right. So during the 1990s, this was a defining decade for modern decontamination. For the first time, the threat of chemical and biological agents reached both the battlefield and the civilian world in ways that demanded newer approaches. Two events in particular, the first Gulf War and the Tokyo subway sarin attack, showed how much progress had been made since the Cold War, but also how much more still needed to be learned. These incidents forced responders, scientists, and leaders to really rethink how decontamination fits into real operations in everyday life. So we'll start with the first Gulf War, which was fought in 1990-1991, and it brought the fear of chemical warfare back to the forefront. Coalition forces were prepared for nerve and blister agent attacks throughout the entirety of the campaign. Now, while large-scale chemical strikes never really came to action, the threat itself shaped how troops operated. For the first time, the MOP gear, the field decon kits, and chemical alarms were standard across nearly every unit. Troops drilled repeatedly in full protective suits under these desert conditions. My favorite example of this is the Jarhead movies. It shows it perfectly. But this was often in extreme heat, to ensure that they could continue their mission even in a contaminated environment. This was also one of the first major conflicts where real-time detection and field decon operations were fully integrated into combat planning. Portable systems like the M11 and M13 decon sprayers we had just talked about, and other absorbent powders such as the M291 skin decon kits were distributed widely throughout the force. These tools reflected decades of Cold War development, but the Gulf War tested them in those real conditions. The experience revealed both the strengths and the weaknesses of the existing doctrine. It confirmed, in most cases, that preparation and training could prevent panic, but it also showed that wearing full MOP gear for long periods of time led to heat stress, dehydration, and fatigue, all of which affected the overall mission performance. So the war reinforced that decon wasn't just about neutralizing chemicals, it was about balancing protection with endurance so that troops could stay operational. So while the Gulf War kept decon in military spotlight, the Tokyo subway sarin attack in March of 1995 brought the issue home to the civilian world. That morning of March 20th, 1995, members of the Aum Shinrikyo cult released a very rough sarin in 5 subway cars during rush hour. 13 people were killed and more than 5,000 were supposedly injured. What made this event so pivotal wasn't just the tragedy itself, though. It was the response. The Tokyo attack revealed, how unprepared civilian systems were for a large-scale chemical event in a very populated area. Police and firefighters and paramedics, they arrived relatively quickly, but most of them lacked the protective suits or decon training for nerve agents. Many responders and hospital workers were secondarily exposed while treating victims who were still contaminated. A lot of the signs and symptoms for this event also were mostly psychosomatic. People that had thought that they were nearby or had heard about it began to rush and overload and overburden the hospital systems. So there were no formal decon lines, no clear triage zones, and very limited communication between any of the agencies. Even with the limited tools, responders did what they could, removing clothing, most importantly, rinsing victims with water, and then ventilating the affected stations. These basic steps are what saved lives, but they also exposed a major global gap. There was no standardized plan for the civilian mass decontamination. So in the aftermath, Japan and the other nations looked at the event very closely. They studied it. Investigators realized that simple actions performed quickly, the removing clothing and rinsing exposed skin, could eliminate most of the hazard. And that finding became the foundation for the gross decon first principle that we still use in mass casualty chemical events today. It also led to the development of mobile decon tents, rapid water shower systems, and better PPE for first responders. The Tokyo attack effectively pushed the world to bring decon planning out of the military sphere and into civilian emergency management. Now, together, the Gulf War and the Tokyo attack essentially reshaped the mission of decon. The Gulf War showed that preparedness and equipment can prevent chaos in the face of fear, while Tokyo showed that those same principles must apply to every community, not just the military. These events reminded the world that chemical threats don't always look like large-scale warfare. Sometimes they appear in subways or hospitals or in city streets. From that point forward, decon became a part of national resiliency, not just that battlefield readiness. Now, in the 1990s, or from the late 1990s to the early 2010s, decontamination had entered another new phase, one that was driven by research funding and focused development. And for the first time, serious investment went into understanding not just how to clean contamination, but how to do it smarter and faster, usually with fewer risks to responders. This period was, I would say, mostly about experimentation. Scientists and engineers looked at novel technologies and tried to make them essentially better. They also explored and looked at new sorbent materials, catalytic and enzymatic technologies, and then getting into the oxidative chemistries that could break down these chemical and biological agents much more effectively. Now, at the same time, responders were still refining their procedures and applications. Some of these were in tandem with these new components and technologies that were being commercialized or materialized, but they were using these procedures and applications now to learn what worked in the field and what didn't. So while these systems were largely water-based, because again, since World War One, that's what we have used because it works essentially. But this era, also laid the groundwork for the modern hybrid systems that we rely on today. It marked that turning point between traditional decon and science-driven decon systems that would soon follow. So when we get into the early 2000s, this marked another major shift in how the world viewed decontamination. For decades, decon had been treated primarily as a chemical response capability built on military doctrine and hazmat traditions. That changed in the fall of 2001 with the biological agent anthrax, where it was used as a weapon on U.S. soil. The Amerithrax attacks, which followed closely after the September 11th terrorist attacks, redefined what preparedness really meant. They proved that a biological threat could reach anyone, anywhere, and that decontamination wasn't just about chemicals or warfare. It was about restoring safety, confidence, and normal operations across entire communities. So between September and November of 2001, the letters containing the finely milled anthrax spores were mailed to media offices and government buildings, including the offices of two U.S. senators. The result was immediate confusion and fear. Postal workers and staff who had handled the letters became ill. 5 people ultimately died, and 17 others were affected or infected. Hundreds of buildings were tested, dozens were evacuated, and thousands were potentially exposed. So for the first time, the United States had to manage wide area biological decontamination in real time across multiple sites with the eyes of the public watching very closely. So responders quickly realized that biological decon was a completely different challenge than chemical cleanup. Anthrax spores are incredibly durable. They can survive in soil, air, and dust for decades if it's left untreated. This meant that typical washdowns and neutralization methods wouldn't really work. The operation required sterilization almost, not just the deactivation of those spores. So to achieve this, teams would use a combination of chlorine dioxide gas, a formaldehyde vapor, and hydrogen peroxide foam systems to treat those contaminated rooms, the mail sorting equipment, and ventilation ducts. Every surface had to be sealed, treated, and tested multiple times to confirm that no spores remained. These efforts took months, not just days. The Brentwood Postal Facility in Washington, D.C., which was one of the primary exposure sites, remained closed for more than 2 years. This was a long, complicated response that exposed major logistical and coordination challenges. There was no single agency with full authority over biological decon. The EPA, CDC, the FBI, all the 3-letter agencies, and the U.S. Postal Service all had these critical roles, but their missions and procedures were different. It took cooperation, clear communication, which is always the biggest failure point, and careful leadership to complete the operation safely. That coordination between law enforcement and public health and emergency response became one of those lasting lessons that has driven forward into the future from the Amerithrax attacks. The event also really, changed how responders looked at and thought about contamination control and public reassurance. During the anthrax crisis, thousands of people were never directly exposed, or who were never directly exposed, still feared for their safety. News reports of contaminated mail and closed buildings created this widespread anxiety. It showed that decontamination isn't just about the science of neutralizing agents, it's also about managing the public's perception of risk. People needed to see clear, organized, and competent actions. And it isn't just about responders and protective gear and controlling cleanup zones, but having that along with honest communication. The visible signs of order and professionalism helped restore a lot of that confidence in communities that had been shaken by that fear. In the years that followed the anthrax attacks, the United States and many other nations overhauled their emergency preparedness systems, funding and training through these programs through FEMA and DHS and HHS, they expanded dramatically. Hospitals began building decon corridors and decon rooms to safely receive these contaminated patients. Fire and EMS departments trained in or began training in mass decon operations using these portable tent systems and rapid shower lines. Federal and state agencies started maintaining caches of PPE, detection tools, and new decon solutions that were specifically designed for biological events. The anthrax attacks also inspired a new generation of research into broad spectrum decon agents, solutions that could safely neutralize both chemical and biological materials without damaging the infrastructure. Many of the products that we see in use today, including some of the environmentally safe enzymatic and oxidative technologies, trace their origins back to studies launched right after 2001. The science moved forward, but so did the understanding that successful decon depends on as much on coordination and communication as it does on the chemistry. So by the mid 2000s, decon had finally evolved into what we now call an all hazards capability, which is designed to handle anything from industrial spills to terrorist events. The Amerithrax response showed that even the most complex contamination events can be managed with training, coordination, and most importantly, steady leadership. It also reminded the world that decon isn't just about cleaning; it's about restoring trust, in the system and in the responders, but also in the idea that recovery is possible, no matter what that threat might be. And I love these pictures. This picture on the bottom right actually shows the one of the early responses for the unit that I was assigned to when I was in the Marine Corps is called the Chemical Biological Incident Response Force, where they had come on scene and deployed to the National Capital Region to assist in the decon operations for the heart building and such. Is kind of close to home for me. It's nice to see that every now and then. But after the anthrax attacks in 2001, decontamination operations from across the country began ramping up both in capability and visibility. However, most of these response teams were still using what many now refer to as the old way, large water-intensive systems that looked much more like improvised wash stations than organized response operations. These systems were born again out of necessity and limited technology. And while they worked, they came with many major challenges, all in logistics, safety, and for me, most importantly, efficiency. So during this period, the standard method of large-scale decontamination often used the 2 or 3 pool systems that we all know and love today. These systems consisted of plastic kiddie pools or containment basins arranged in a certain sequence, typically for washing and rinsing. Responders or victims would and could step into one pool to be scrubbed with a soap or detergent, then move to another for a rinse. Sometimes a third pool was used for a secondary wash or to capture some of that runoff. The idea was to create a controlled flow that reduced cross-contamination while removing the visible debris and the potential agents. So in this practice, the system was difficult to manage. Pools overflowed easily, runoff water mixed contaminated and clean materials, and maintaining the consistent chemical concentrations at each station was nearly impossible. On top of that, responders had to physically scrub victims with long-handled brushes while wearing full protective suits. This was extremely labor intensive, very slow, and very physically demanding. In many cases, the responders themselves ended up contaminated or overheated, adding further risk to the process. Now, despite those drawbacks, it remained the acceptable model for years simply because it was the only widely known method. Another variation from the same time period was what many responders still call the car wash style of decon. This approach involved setting up multiple shower hoses, garden sprayers, fire nozzles, all using large volumes of soapy water to rinse entire groups of people or equipment simultaneously. It worked for flushing away dirt and debris, but was extremely inefficient for chemical or biological agents. The amount of water required was enormous, often overwhelmed the containment systems or storm drains. The runoff created its own hazard, which was potentially spreading contaminants further downstream. Now, the car wash method was fast, but it was extremely messy. It lacked control, over the contact time, the water temperature, and then coverage consistency, making sure that people were getting a full layer of coverage with that decon agent, whether it was soap and water or something else. Still it gained popularity because it was easier to understand and relatively simple to set up. and it gave the visual impression that something was being done. And how many people can say that they still do that today? Now, many communities and agencies relied on this type of system for years, not because it was the best option, but again, because it was what they had. These older systems taught valuable lessons that shaped more modern decon doctrine. They highlighted the importance of containment, the need to control wastewater and runoff, and the value of simplifying decon so that it could be performed by smaller teams under pressure. They also revealed the human side of decon, how cold water and exposure and privacy concerns affected a lot of victims, and how responder fatigue could slow operations. All these experiences fed directly into the push for smarter, cleaner, and faster systems that would follow going into the next decade. Now, while the older methods might still look crude in some cases by today's standards, they deserve credit for bridging that gap between the early civil defense efforts and the modern hybrid systems that we use now. They represented this turning point between brute force decon, again, massive amounts of soap and water and scrubbing, and a more measured approach based on chemistry, absorption, and surface science. Every modern tool that we use today, from dry decon wipes to enzymatic neutralizers and all the cool, crazy stuff, was born out of the hard lessons learned from those kiddie pool and car wash setups. All right, so here's something I want everybody to think about. These two images are separated roughly by 100 years. The left photo is from an early military decon line, and the right one was taken just a few years ago at a modern training exercise for the National Guard. Now, if you look closely, what's changed? And I always make the joke that we obviously developed shorts, but truthfully, both of them still rely on water and soap and physical actions, whether it's scrubbing by a technician or by the contaminated individual. Now, they are relatively different, but the concept still stays the same. They're the rinse, scrub, and rinse again, which, for decades we've just made the process a little bit cleaner and safer and not necessarily more efficient. So for me, this slide really puts it into perspective. After a century, literally a century of advancement in chemistry and materials and engineering, our decon lines still look familiar. And that's why the evolution, the hybrid systems, is such a big leap. Instead of relying on endless water and manpower, we started asking a new question. What if we can make decon smarter instead of just bigger? Now, this slide, shows where the real turning point began. From roughly 2012 to 2017, the industry started applying decades of research into new and practical systems. The investments became more focused on better sorbents and the catalytic and enzymatic chemistry. The oxidative technology helped transition us from the traditional soap and water mindset toward a modern hybrid style decon. The focus wasn't on using more water, more people, more time, but on using the better materials, better chemistry, better processes. This is where decon finally began catching up to the technology available, setting the stage for the hybrid systems that we rely on now. So, by 2015, responders around, the world really began looking to move away from the large-scale, water-heavy systems towards smarter and more adaptable methods of decon. Years of experience with the older pool and car wash setups had shown many limitations. They were slow and labor intensive and created just as many challenges as they solved. Now, in remote and resource limited environments, these systems just weren't practical. The field needed an approach that could be scaled to the situation when required less manpower, less water, and still achieved the same level of safety and effectiveness. Now, this began the rise of hybrid decontamination, a system that's built on combining the best of dry and wet and technical methods into this one flexible process. The philosophy behind hybrid decon is very straightforward. Remove as much of the contamination as possible using the least amount of time, water, chemical solutions, while also keeping responders protected and the environment and the environment controlled. Instead of treating every incident like a full-scale washdown, responders began using a step-by-step approach that allowed them to adapt based on the type of contaminant and the operating conditions. The process for hybrid decon typically begins with a dry decon phase, which has become much more of a focus as of late, which focuses on removing bulk contaminants before introducing any liquid. Absorbent wipes or pads made from carbon-based or layered materials can safely lift and hold liquid or particulate come from this as well. The old wipe spray wipe to the newer methods of blot apply remove. This is especially useful in cold weather, inside structures, or when water supplies are limited or non-existent. This is where things like fibertex became, begun to shine dramatically, because it has those capabilities to not bring any more of a quote unquote problem, right? We're bringing a dry adsorbent material to conduct the initial phase, the initial step of decon, and then following it up with whatever is necessary past that. So, this is great for being able to bring it to, bring the decon to the problem versus that old concept of bringing the problem to decon. So this also helps us reduce the amount of runoff that needs to be captured and disposed of later. Following the dry decon phase, we get into a wet decon phase, when this is where we look for neutralization or more physical removal. Usually, we need to reduce surface tension to help with the physical removal. So some of the modern liquid decon solutions are designed to be non-corrosive and non-toxic and broad spectrum in their effectiveness. They can break down a wide range of chemical and biological hazards without damaging equipment or posing secondary hazards to responders. These solutions, they can be applied with hand sprayers. Some of them are through wipes, or soft brushes, depending on the surface being treated. This allows for a precise, adaptable control, which is a major improvement over the older practices of spraying large areas with soapy water. There are some present-day solutions that focus solely on destruction of a hazardous material, which in most cases just isn't practical. The final phase, often called technical decon, focuses on cleaning tools and instruments and protective equipment in these controlled settings. And this allows, or ensures that responders can safely remove and reuse essential gear without risking the cross-contamination. Now, modern technical decon setups are much more modular and portable, meaning they can be scaled up for these large events or condensed for team level operations. And the picture on the right shows exactly that, where we've taken a traditional 3-pool decon line and we've compared that to the enhanced decon system that we have started to implement really from coast to coast, and in some cases around the world, where we now have a much smaller footprint, much less on the logistical effort, which improves that capability of response, mostly on time, because I don't have this overly laborious setup. I have a quick 2 to 3 minute decon setup, and I can adapt that whether I'm on the 5th floor of a building or the 50th floor of a building. I'm on a stairwell, I'm in a hallway. My capabilities become much more broad as I'm able to adapt to that situation. So, this shift in development, it was also a huge move towards modular decon systems. The kits and setups that allow responders to adjust their operation based on the size, like I had mentioned, the complexity, but also with the environment. So now, instead of hauling these large trailers or permanent structures, teams can now carry compact packages or bags containing everything that's needed for dry, wet, and technical decon processes. These modular systems made it much more possible to conduct complete decon in urban areas, field settings, or even in remote locations without the heavy infrastructure. Now, the shift to hybrid and some modular systems brought several key benefits. It reduced the decon time dramatically. The speed of decon is key. Now, that allowed for safer and more efficient responder workflows and cut down on that environmental impact of the wastewater disposal. These methods also addressed some of the more common issues in traditional systems, the responder fatigue especially. Now, by simplifying the process and minimizing physical strain, hybrid decon improved both the safety and endurance for the teams carrying it out. So today, hybrid decon has become the standard across both military and civilian operations. It reflects more than just a change in equipment. It represents a change in philosophy and in mindset. Decon is no longer viewed as a one-size-fits-all task, but as a flexible, layered approach that can be adapted to a situation or to the situation at hand. Whether it's in a hospital corridor, a city street, or it's on a field deployment, the same principles apply. Act quickly, contain the hazard, minimize waste, and protect the people performing the work. This evolution from mass water-based systems to the modular hybrid operations has made decon more practical, much more efficient, and way more sustainable. It stands more as a result of decades of experience, a balance of science and simplicity and operational sense that was shaped by those that have had to make it work in these real conditions. All right. So, this is another slide that kind of shows where decon is moving towards today from 2017 to now, and honestly where it's headed. So, by 2017, that shift, the shift of focus from invention to refinement, we now have core technologies that are in place, or in some cases were already in place, advanced sorbents and catalytic chemistries and these safer liquid solutions. But what changed was how they were packaged and deployed and improved. This was this time marked the rise of user-defined systems where modular decon kits could be customized for different missions, for agencies and climates. Instead of a generic top-down solution, responders now have equipment built from their feedback, real world input, which, what worked and what didn't, what needed to be faster or more simple. All of this goes straight back into the design. Now, companies working in this space have learned that progress isn't just about formulas or fabrics, it's about listening to those in the field. Now, every incident, every training event, every after action review contributes to the next version. The feedback cycle has become the engine of innovation, so to speak. This loop from user to manufacturer and back again is what defines the future of decon. It's no longer about creating a single best system, best option. There is no one silver bullet that does it all. It's about continuous improvement, making tools safer, more efficient, and more adaptable with every iteration. Now, the result is equipment that evolves alongside the people who use it, keeping the pace with those changing threats and environments. All right, so please forgive me. Please forgive me and my AI decon pictures. We tried, but as technology advances, so does the way that we think about decontamination. Over the past century, decon has evolved from improvised bleach buckets to integrated hybrid systems incorporating technologies like Dahlgren Decon and FiberTech, where the next major step is going to focus on automation and precision and sustainability. The goal is still the same as it always has been, to protect people and restore function, but the methods are becoming smarter, faster, and more adaptable than ever before. The future of decon is moving toward automation and robotics. Autonomous systems, including drones and ground-based robots, are being developed to apply decon agents without direct human contact. These systems can operate in contaminated zones that would otherwise be unsafe for responders, industrial sites, chemical plants, or even radiological hot zones. Robots equipped with sprayers and UV systems or plasma emitters could handle these large-scale cleanings while operators remain at a much safer distance. This technology is already being tested for industrial cleanup and disaster recovery and will very likely become a standard part of a CBRN response over the next decade. Another key area of this is of the progress is material science. Engineers are designing self-decontaminated coatings and fabrics that can neutralize contaminants on contact. These coatings rely on catalysts and nanomaterials and other embedded enzymes that react with hazardous substances, breaking them down automatically. Protective suits, vehicle exteriors, and interiors, building surfaces, all these made with materials that could drastically reduce the need for follow-up decon. So instead of cleaning contamination after exposure, the surface itself becomes a part of the defense. Sustainability, like I had mentioned, is also becoming a major focus. The traditional approach to decon, large volumes of chemicals and water, is being replaced by, we'll call it green chemistry and environmentally neutral solutions, right? These formulas are, in most cases, non-toxic, biodegradable, and effective against a wide range of threats without creating the secondary waste streams. This really aligns with the global environmental standards, the view and the way that we're trying to move forward and help agencies reduce cost related to waste disposal and long-term cleanup. Another area that drives from this progress is data integration and decision support. Future decon systems will likely incorporate sensors that monitor contamination levels in real time, which allows responders to know exactly when and where decon is needed. Digital mapping and modeling will help predict how contamination spreads through the air, water, or even on surfaces, which will help guide those teams to act much more precise instead of broadly. Artificial intelligence isn't it's not replacing responders, but it's likely going to enhance the coordination, helping incident commanders visualize contamination zones and track the effectiveness of each phase, including decon. Now, the human factor remains just as important because as these systems grow more advanced, training will now shift towards managing those technologies and interpreting the data rather than the manual application. Responders are going to need to understand not only how to operate the tools, but also how to adapt procedures when technology fails or conditions change. Decon's always going to rely on skilled professionals who understand both the science and the reality of field operations. Ultimately, the future of decon is about control and adaptability. The trend is moving away from the brute force cleanup towards and is going towards precision response, systems that use the right amount of chemistry, the right tools, but also the right timing. Now, the goal is to it's a process that's much faster, safer, and more sustainable no matter the environment. So whether it's that city street or, as I mentioned, the hospital or the battlefield, decon is becoming much less about scrubbing surfaces and more about restoring safety through the technology, design, and coordination. We've come a long way since buckets and brushes. The next generation of decon is it won't just respond to contamination. It's going to anticipate it. It's going to contain it and hopefully neutralize it before it spreads. That's the direction that this field is heading, and it reflects a century of lessons from those who've had to improvise under the pressure. So as we start to close out, right, I want to look back through more than just a century of decontamination. It's clear that every generation, every era left behind lessons that still matter today. The tools changed, the threats evolved, and the environments became more complex, but the principle stayed the same. Decon has always been about protecting people, preserving capability, and restoring safety as quickly as possible. From those improvised methods of World War I to the organized chemical units of World War II, from the Cold War readiness to these modern hybrid systems, every generation has improved on the one before it, which is great. The field has grown from washing trenches and vehicles to protecting entire cities and hospitals. What once took dozens of people and thousands of gallons of water can now be done by a handful of trained responders with these portable systems and precise chemistries. And that progress didn't happen by chance. It happened because every failure, every near miss, and every successful operation taught us something that we carried forward. So there are those three key lessons that sum up everything that we've kind of talked about today. First, speed saves lives. The speed of decon is key. The faster we act, the better the outcome, not only for those exposed, but for the entire response effort. Second, safety protects responders. No decon operation is going to be successful if it endangers the people doing the work. The best systems are those that reduce risk while increasing control. And thirdly, simplicity ensures success. The most straightforward and repeatable a process is, the more likely it's going to hold up under those stressors. These three ideas, the speed, safety, and simplicity, are crucial. They're timeless. They've guided every major advancement in decontamination and will continue to do so going into the future. So looking ahead, the mission still remains the same, but our approach is what's going to keep evolving. The future of decon is one of precision and efficiency and collaboration, the military and civilian responders working side by side with tools that reflect both science and field experience. Our focus will continue to shift towards sustainability and automation, but also proactive design, because at its core, decon will always depend on people, the trained professionals who know how to think and adapt and act decisively under pressure. So before we close, though, I'd like to open up the floor for discussion. I want you to think about your own experiences. What methods have worked best in your operation? What challenges still exist in your areas, your regions, or within your agency? The conversation that that follows presentations like this is often where the next real improvement begins. Whenever we conduct our train the trainers in Fredericksburg, the first thing we ask is, how long have you been doing this? How much experience do you bring to the table that we can have a well-developed discussion and potentially provide a better way forward? So the story of Decon has always been the one of progress that's shared through knowledge. It's by shared knowledge. By continuing to learn from each other, we keep building the safer, faster, and smarter way to respond, no matter what that next challenge looks like. So, like I said, I want to open up the floor for discussion, see if there's anybody that has any questions. I would absolutely love to answer them, and I will stop talking and see if there's anybody there. I'll also turn my camera back on. If you don't have any questions, if you want to put it into the group chat, we can talk about them there. Danielle, do you see, or Elizabeth, do we see anything in the chat?
Jason Curtis here, real quick. Do y'all have anything on your website that, as far as the Dahlgren, I know we use that system, to know what we can use it on versus setting up the car wash trial thing that we continue to do every day?
Absolutely. So one of
So
the
we can
one of the
speed that process up.
Absolutely. So one of the cool technological things that kind of came along with the development of things like Dahlgren Decon was our ability to create the Decon field guide, where it is specifically focused at Dahlgren Decon, where we can use that information once we've created an account, of course, which is free. We have this threat index where you can search for individual threats by cast number, by the name, by synonym, and it gives you a very quick and brief way forward of utilizing Dahlgren Decon specifically, but it also gives you an idea of other products to not use. So what I want to mention on that is that Dahlgren Decon is an oxidizer. If there is a contaminant that's in the Decon field guide that says do not use Dahlgren Decon or dry Decon only, that gives you a way forward with another product of saying, well, I probably shouldn't use an oxidizer on this contaminant because it might have some type of incompatibility. So to the long and short answer to your question is that the Decon field guide provides a lot of those answers relatively quickly for you. We just ended a large update into that threat index, adding a little over 100 new threats to search for and from. So hopefully that answers your question.
It does, and that's an app-based field guide, correct?
Correct. We have an application based that is available through the Apple Store and the Google Play Store, but it's also a web-based version as well, which can be found by searching Decon Field Guide on Google or going to deconfieldguide.com.
Okay, thank you.
Absolutely, yes, sir. Do I have any other questions?
Hey, Frank, Kent Worry, Aberdeen Fire Rescue in South Dakota. Hey, we use this Decon system just because of our environment that we are in. We get cold temperatures, negative at sometimes. So, if anyone's out there that, is curious about the stuff, we do use it here in South Dakota. I know there's some departments in North Dakota that use it too. But we just had a hazmat training with our hospitals and stuff with it. So we had it out showing them that what we can do before people get to their hospital, and either if they get a call saying there's people coming to the hospital with stuff on them, that we can deploy it in like less than 3 minutes and stuff. So it's a great product. We used it. The only thing what we're confused about, not really all of us, but some of us, about deconning people. I know we cannot use this on people as of yet. We did put Dawn's soap in our kit just for that aspect. it's on, someone else. But I guess what's your thinking of Dawn soap on people? I know we've used Dawn soap for years and years and years before this product.
No, for sure. And I mean, that's kind of I would say the industry standard. So, um, Aberdeen, North Dakota is North Dakota, right? I want to make sure I got that right. South Dakota.
South Dakota.
South Dakota, right? I always get those two confused. It gets quite cold. So when you have to apply, solutions that are soap based or water based, you either want to try and minimize the amount of that product. And one of the joking questions that I like to ask people, going forward is when they're using Dawn is where do you find the dilution ratios for how much Dawn is needed on a given response on a given person? And it's a joking question to a certain degree, but the realistic answer is that there is no dilution ratio. There's, most people say they squirt it into a bucket or into a sprayer until it smells right or until it looks right. So, I mean, in those cold weather environments, especially using is minimal amount of product as possible is one of the key efforts for that. And that's why we've started focusing so much more on the dry decontamination efforts using things like FiberTech, where we remove as much of a product or a problem as possible and either call that the only necessary step, or it allows me to minimize that usage of a water-based decon product, whether it's the Part A and Dahlgren decon, which allows you to use much less, or you have to use Dawn or any of the other commercially available soaps.
So Frank, you would more recommend us using the FiberTech wipes than even worrying about the Dawn soap in the pump sprayers and stuff like that.
In most cases, absolutely. There's going to be very few and far between chemical threats that Dawn is going to be extremely efficient on. What those are, I of course can't come up with those off the top of my head, but we could definitely look at what those threats could potentially be. But FiberTech is going to give you that immediate all hazards, um, tool to apply to that problem and at least remove as much of it possible to get to that life-saving step. Because one of the other things I try to make as much humor as I can out of decon, but one of the big concepts that I was taught going through all the decon courses that I have it was specifically that nobody dies in decon. If your decon process is delaying someone from receiving a life-saving treatment, your entire process needs to be reevaluated. So to answer your question again, the long and short is I would immediately apply FiberTech as my initial solution and then do spot decontamination where necessary with a water-based in those colder environments.
Perfect. Thanks, bud.
Absolutely. Thank you, Ken. Appreciate it. I see a hand up if you want to go on ahead.
Chris Neckfatal. I'm sorry I didn't put my last name. Can you hear me?
Yes, sir. Absolutely.
Oh,
Gotcha.
Chicago Fire Department. Not only the Dahlgren, but the FiberTech has, besides the application that you're describing, whether it be a formal decon to minimize, runoff and a lot more waste. We use it, or we do have it on our packs for JHATS, which is a Joint Hazard Assessment Team that we use for special events in Chicago, such as the Air and Water Show, Lollapalooza, stuff like that, where we could use the FiberTech wipes and use them, a quick and systematic wipe when we might not have the resources of a showering system, or as people were saying, a Dawn dishwashing soap and spray it. So for a quick wipe, the FiberTech, using in that application for that type of scene and scenario is effective for us. Going back to what you were saying before about, 100 years of doing, not to say the same thing, but we're relatively doing the same concept of doing the showering method. And I understand the concept. It's labor intensive. You need a lot more manpower. It's a lot more exertion, depends on the weather. And if you had, I guess, my friend from North Dakota being 0 degrees, we do get some 0 degree days in Chicago. I think the FiberTech would work, but if you did have the option of using the pool method and the manpower is effective also. The Dahlgren, we haven't used that much of. But I'm sure we're going to be using it in the future. We have all these things at our disposal.
No, absolutely. And I mean, the presentations and the classes, whether it's at a conference or, in-person trainings that we tend to come to, we never want to be that driving factor of you should just throw away everything that you have in stock and in storage and buy our stuff. Now, granted, don't get me wrong, our sales guys would, I'm sure, absolutely love that if you did that. But it's not to say that, this is the end all be all way, because just as we've noticed from World War One all the way up to now, is that technology does get better. And there are much more effective and in most cases beneficial ways to do decon. So if what you have is working for you, that is fantastic. If you could find different ways to implement different technologies into that process, because again, the 200 years of tradition unimpeded by progress conversation
Yeah,
comes up a lot.
that's the
So
truth.
it's as long as you have the ability to implement these new technologies and in ways to where it's just more generally beneficial to the process, usually the better off everybody is involved. So it's great that you guys have the products and the components, but I'd be remiss to say that if you don't have something like FiberTech, using anything that's available as an absorbent, a cotton towel, a shirt, a hat, I mean, whatever you have to remove as much contamination as possible as that first step before the water-based decon, it's just generally better. It's going to reduce the amount of the stuff that you're going to have in your effluent, the dirty wastewater. It's going to start that process for your patients or for your responders earlier on, so that way they're not just sitting there twiddling their thumbs and waiting for that next step.
One additional thing about the FiberTech, what I do like about it being an absorption or an adsorption type of medium, when it does absorb or adsorb the product, whether it be CWA or tick or an emerging threat, when it absorbs, that does an off gas. So
Yes.
having that option compared to have a quick paper towel, which I'm all in, of course, but having that quick wipe and now it's controlled, pretty cool.
No, absolutely, and that's one of the things that really sets FiberTech, apart from all the other things out there, is that it has the ability both to act like a sponge and then bring the sciencey component into it and adhere a lot of that, volatile vaporish material that likes to bind to that activated carbon layer, and it prevents a lot of those issues. Whether it's you're removing it from a surface or from somebody's skin, but also standing in it and some of those decon shuffle pits that you may or may not have seen. Now instead of standing in bulk liquids or bulk materials, you're now standing over a vapor controlled area, or at least a relatively vapor controlled area. Now that's important for responders, but I'd say 95 to 99% of the time, most first responders that are utilizing systems like the enhanced decon system or the EDS are going to be in respiratory protection, typically in SCBA, where it changes that focal point is with patients and civilians in the event they need to come through that same system because it's the only option. Now they are in a vapor controlled environment where respiratory protection, of course, is still a prime concern, but it's not I guess now the biggest concern, right? Because we're able to control that. So no, it does very, very good at both absorption and adsorption.
Thanks, Frank.
Absolutely. Thank you. Do I have any other questions?
Hey Frank, you got quite a few in the chat.
Okay.
If you want to take a look at them, or I can read them to you as well.
If you could read them out, that would be fantastic, because I have no idea how to get to the chat.
Sure. I'm just gonna read everyone's first name so I don't insult anybody. First one's here from Mark. Even if deactivation neutralization is not the sole mechanism for success, how long does neutralization take?
Great. I mean, that's actually a really good question. So there are a lot of different technologies out there that pride themselves in very quick decontamination, whether it's through an impregnated glove or a wipe or a neutralization agent like Dahlgren and Decon. Um, it it depends, and I hate saying that it depends, but it truly does, because when we start looking at what the hazmat threat might be, we have to assess those physical and chemical properties, and that's what's going to determine essentially the level of the response. So when we say, I have a volatile material, I may not need to apply any type of decontamination material or decontamination operation to it. I'm just going to allow a gas to be a gas. Now, there are different things to do for those situations, but when we start looking at, physical removal being the primary focal point for a lot of decon operations, I might not have to worry about neutralization. I can go in there and capture and collect as much of it as possible and bag and tag it and treat it as haz waste. And I don't have to worry about anything from that point. So I hope that answers your question for that. And then, okay, so I have the chat up now. So I think I elaborated a little bit on FiberTech. There are a lot of different technologies out there that pride themselves in being a glove or a dry decon glove or a dry decon wipe. The biggest factor that I think separates FiberTech from those other similar products is it doesn't have these adhesives and other chemicals that are impregnated or within that material or within that fabric. It is solely what comes in the package of the polyester or the unbleached raw cotton, depending on the version of the formulation that you get with that inner layer of activated carbon. It's manufactured in a very specific and precise process, and it's designed to stay together and withstand, just about everything that we have tested it on or had it come into contact with. So again, I hope that answers your question as well for that. Let's see. Can you comment on FiberTech or for fentanyl absorption or for Decon? So I think I kind of mentioned it as well, or at least the other gentleman had mentioned it. When it comes to using FiberTech on things like fentanyl or these other fine particulate powders, it is extremely effective. Now, I had mentioned that manufacturing process of how it's designed and put together very specifically in a very specific manner. It allows for, for the lack of the right terminology, has these nooks and crannies, very, very microscopic areas, with a ton of space to allow those very fine particulates that you're going to see for your fentanyl powders, your fentanyl HCLs and such that you typically see on the drug scene. It helps bring that material in and capture it within the fibers of the FiberTech. So it does a very good job. But for things like fentanyl, because of how fine it is, you are going to want to incorporate some type of surface tension reduction or a surfactant to help remove or further remove that product from that surface. So things like the Part A in Dahlgren Decon or the Dahlgren Surface Clean, which is that raw concentrate surfactant, if you have the ability to dilute that down, again, having a really good surface acting agent is going to help pull that material off, but also make it a little bit easier to absorb into the FiberTech, because now instead of doing a dry on dry decon, a dry FiberTech wipe with a dry particulate powder, you've now created a solution with that water-based form of decon to make it a little bit easier to absorb. Now that's not applicable for all particulates, but for fentanyl specifically, that would be. Let's see. So one of the other questions that I see is how many chemicals is Dahlgren Decon approved for at this time? Last I looked, it was 130-ish. I do not have, I apologize, the exact number right now, but we, I believe, have just crossed over into the threshold of a little over 200 with that most recent update as about a week ago. Let's see. As an inventor of FiberTech, I guess Dr. Ram is here. Hello, sir. Glad to know about its effectiveness. First Line Technology did a good job in taking it forward to this level. And, it's with those efforts that, we constantly have people in this field that are looking to move products and move technologies and forward into the future with better advancements and better capabilities is great, because once you stop innovating, outside of the business realm, it becomes dead, and that drastically limits the capabilities and the abilities of responders and militaries and healthcare moving forward. So we appreciate you as much as you appreciate us. So one of the last things that I see in the chat though is it says in Canada we use mainly dry decon on drug labs unless grossly contaminated, which is basically peeling off suits and gloves carefully by decon teams in PPE. Is this common in the U.S.? So this is something that I would like to see change going towards or going forward in the future. Not the dry decon piece, but the way that we remove our levels of protection. So one of the things that we typically get questioned or asked about in some of the trainings is, why does First Line teach a cutout process versus a standard doffing or removing of protective equipment. One of the big things that I look at is with this advancement of PPE, we've started to develop thicker and more durable materials, which makes it harder in some cases to do the standard doffing or removing of that PPE, which could potentially disrupt the seals that I have for respiratory protection. So if I'm in a vapor hazard environment and I disrupt that that respiratory protective seal, I'm opening myself up for many different avenues. So if you look at all the different response agencies and organizations, you're going to notice that there is no one set standard that everybody is going to do in most cases the way that they have done it, which is neither here nor there. But some people have a very good standard of process for removing that material. The reason, again, why I mentioned we do a cutout process is because I can almost guarantee with a 99.9% certainty that I can get someone out safer through that cutout process versus the doffing process, because I don't inhibit any of the respiratory protection hazards. I can control, in most cases, that PPE much better and much more effectively. So let me go back to the question, because I do tend to get a little sidetracked. So we use mainly dry decon on drug labs unless grossly contaminated, which is great. That allows you to do very targeted and specific decon, whether it's capture and collection or whatever it is that you might be trying to do. And that very well could be a good reason for you to peel out of those suits, as you had mentioned, because you're not getting grossly contaminated. So again, to answer the back end of that, or the backside of that question about what's being common in the United States, is it really just depends. And I don't see any other questions down on here, but if anybody else has a verbal question, I'll give you a few seconds to chime in or raise your hand. All right, and I guess silence is consent in that case. Not in real life, everybody. Don't take me literal on that. All right, so coming to the final slide, right? This kind of brings us full circle. From the first crew decon lines of World War I all the way up to the hybrid systems that we're using today, decon really has come a long way, but it continues to evolve because of that feedback that I had mentioned in those earlier slides. And this allows us to update, upgrade, and continuously innovate going into the future for all the technology that we have, right? Whether it is Dahlgren Decon and FiberTech and some other things, right? It allows us to continue that innovation moving forward. So I will mention, though, if you want to learn more about specific systems, specific kits, more about Dahlgren Decon or FiberTech, we have some really awesome YouTube videos that my boss Corey, there in the top center of the screen, has done in the past, and I'm sure he would absolutely love it if you view those. He is he's done a very phenomenal job of getting a lot of the information recorded and getting it put up onto our YouTube site. Outside of YouTube, we have resources like the Decon Field Guide, but also our newly renovated website as well at firstlinetech.com. You can view the products, you can view the kits, the individual information for specific technologies. And if that's not your go-to thing, you can absolutely reach out to the three of us at any point in time. This is I would say, the face of our technical department, missing one person, Daniela, who's kind of the one of the coordinators for getting this whole webinar going. But between the three of us, we typically try to answer questions as fast as possible, which allows us to, provide you as the end user or the customer, even if you're not a customer, at least a way forward and give good information. That way everybody's safe. Because for me, that's what matters is everybody doing their job safely and coming home at the end of the day. So, on behalf of our team at First Line, I appreciate everybody's time and attendance, and then most importantly, what you guys do to keep the community safe. So, from here, I'm going to close it out, and I look forward to hearing from people in the future. And I don't see any other questions that popped up. We look forward to hearing from everybody in the future. Thank you all very much.